Big data is the latest overhyped IT buzzword, but what does it mean, and is there substance behind the marketing hysteria? The term describes the torrents of complex and hard-to-manage datasets that emerge from sensor networks, weblogs, social media, scientific records, internet search indexing, and many other similar activities. The problem centres on the fact that this data is often unstructured and therefore hard to fit into the standard relational database tools that companies are familiar with. However, some industry experts believe that these tools can still be used.
I don't like the term unstructured data. If data is being made by a machine, therefore it is pretty structured. It might be a bit dirty, and there might be a bit of you might need to use some slightly fuzzy matching on it, but again, that's fairly traditional database techniques. And it might be a process, a big data process might be whereby you take some kind of fairly disorderly data, maybe from a large log file, and structure it into a nice pristine database.
The use cases for big data are many and varied. Based in the International Space Innovation Centre near Oxford, Mark Curtis, Technical Design Authority at satellite mapping firm Infoterra, processes data from a network of satellites which produces the images we all see on Google Maps.
So we started back in 1992, in reality, ERS-1, and we've been storing data for certain instruments of that on behalf of the UK for all that time. So we have hundreds of thousands, millions of files, including all the metadata files that's associated with these products. So the whole point of the pack itself is actually to reprocess this data when the scientific algorithms change or when there is a requirement to do, say, comparisons between products, and the scientists or the customers require a whole new data set to be reprocessed. And that really is its whole job. That data itself, of course, is unstructured and it just sits in very large file systems. So they also store the aerial survey of the UK, the high resolution version of which, and when I say high resolution, I mean 12.5 centimetre resolution, was also delivered to Google. So if you look at Google Maps, you'll find that data there. So again, that's another data set. So if you think about the UK on its own is 230,000 square kilometres of data, all of which has to be stored in an unstructured way. That is then processed actually into a lot smaller image files, which we then make available via web services.
Kate Craig Wood is running her own big data project, but unlike many experts, she says that she doesn't need to recruit new staff or invest in new tools to do so.
A few years ago, we took the decision to have one master database and actually deliberately simplified our system. So we just use a big MySQL database. And again, we've moved some of the intelligence into the software with Django, so we don't have stored methods and things. So we can have a very large database. But then 2 years ago, we decided to start going to kind of taking it to another level. And we started logging every one of our virtual machines and servers for power usage, CPU utilization, RAM, everything you can think of, about 15 different parameters every hour. And over the last 2 years, we built up a data set with tens of billions of data points in it. And actually, it's in a big kind of a CSV file. So some people might call that sort of semi-unstructured. And I thought I was going to have to use quite big data techniques. But I thought the first step was try and kind of order the data a bit. And I put it into an SQLite database because that can take, it's unlike SQL, it's MySQL, it's very good at taking very large numbers of rows, but you lose some of the functionality. So it's like a step towards big data. And it did take about 2 days for quite a powerful machine to crunch through this enormous file and get it into a relational database. But once I got it there, I've been able to do analysis on it with queries only taking a couple of minutes, which is, for a non-real-time application, perfectly usable. And we've been able to take the findings and apply it to our VM architecture over the last, so it's been a project we've been running over the last year, kind of the analysis. And as a result of this, the energy efficiency of our virtual machines is more than doubling every 18 months. So we're actually beating what Moore's law prediction, because Moore's law actually does somewhat apply to energy efficiency as well. So it can have real benefits. But when we started out, it was a bit kind of, let's kind of collect all this data and see what comes out of it.
Once data has been captured, one issue that appears is storage. As the term big data implies, data volumes can be huge, reaching well into the petabyte range.
We have two main components. We have a very large Hitachi enterprise arrays, which actually are the caches for the whole archive in the file store. And then we have a StoreNext system on the back of that from Quantum, which actually is a hierarchical managed system, which actually allows us to integrate disk storage. So into a single namespace, we get disk storage and we get tape storage. So that is really the component that we're using to store our data and manage it. It also has its own database, because the way that this particular product works is it's a policy-based hierarchical system, traditional block storage, which allows you to put in a file. You can then mount that file system. It's heterogeneous, so we can mount it on any version of any operating system we require. Most of our processing is done in Linux, in reality, just for speed and performance. And then we can access that data from anywhere and read and write it from anywhere.
With the data safely stored, Infoterra then used metadata to help in its analysis.
So when that data comes in, associated with it is a metadata file. The header of that file has already been processed to give us satellite times, beginning and end time for that pass, so we know where that data is. And that's the main catalogue that you're going to use. As a user, when you come in, you're interested in two sorts. You're interested in on-demand processing and you're interested in routine processing. When you run the routine processing, you will literally routinely process all of these data to higher level products. When you're doing on-demand processing, of course, then you need to search catalogues more. We all need catalogues to find out where this data is, spatially as well as temporally, and which is quite important. So that data is then absorbed into that catalogue, and then that catalogue's used.
So how could big data benefit your business? Kate Craig Wood advises companies looking at the possibilities to start with their own website.
And I'd say the first port of call is, it's always a website. It's always a good place to start. If you're not getting your website records into a database structure, you should be, I would say. And if you have a large, some ancient log files, that's probably quite a good project to kind of take those and then structure them in a database format. We found that enormously powerful. We can now do precise return on investment analysis on various different publications and kind of marketing channels, and actually see down to the level of customer loyalty. For example, we've discovered that customers that come to us from natural search on Google are more loyal than customers that come to us through Google AdWords, which is kind of slightly surprising, but not quite sure why. So I say that's a good first port of call. If you're running a large machine estate, again, it's great. If hopefully you're using power bars with where you can meter the individual sockets, measure the individual sockets via SNMP or whatever it is. Make use of that. Start collecting that data on maybe an hourly sampling basis. There's freely available software so that you can monitor the load levels on servers. Again, go and start doing that. Start kind of gathering that data up.
So, big data holds potential benefits for almost every business and doesn't necessarily demand a large investments in new tools or skills.